There are two ways of getting lift. The first we already talked about, and that's increasing the angle of attack. The second is increasing speed. If you increase the speed, you will increase the airflow over the top and the bottom of the wing, which will create more high pressure on the bottom and more low pressure. So there will be a bigger difference in pressures, and that will produce more lift. And a little fun fact, if you double the airspeed, you will quadruple your amount of lift. Here's the leading edge, the trailing edge. The curvature is called the camber. Chord line is between the leading and the trailing edge. The angle of attack is between the chord line and between the relative wind, which is opposite of your flight path. The critical angle of attack is the angle at which the wing stops producing lift. And the only way to get lift back is to reduce the angle of attack so that the airplane can start flying again. So airplane wings produce lift, no surprise there. But the propeller produces lift, so does the elevator and the rudder. And before we get ahead of ourselves and talk about that, let's talk about stability. You know that the center of gravity is where all the weight is concentrated. Center of lift is where all the lift is concentrated, and that's usually pretty close to the center of gravity. Now, if that's all we had, you'd have the front of the airplane going down and the back of the airplane going up. So the airplane would continue in a circle were it not for the horizontal stabilizer. The elevator, which is on the horizontal stabilizer, produces lift downwards, and that helps counteract that forward turning motion that would happen if the horizontal stabilizer wasn't there. Now the center of gravity and the center of lift have to be in the right relationship to each other. If you had the center of gravity behind the center of lift, you'd have the horizontal stabilizer pulling the airplane down, you'd also have the center of gravity pulling the airplane down, and then you'd have the lift in front pulling the airplane up. So what would happen is the airplane would flip on its back and it would want to stay that way. And that's bad. You don't want to do that. That's how you get into an airplane stall. So the ideal scenario is where the center of gravity is in front of the center of lift. That way, if you get into a stall and the wing stops producing lift, you won't have the up force anymore, but the center of gravity in the front will be able to pull the airplane down and reduce the angle of attack. So that's really good. Keep the center of gravity in front of the center of lift. And you will notice this when you practice stalls, because the airplane nose will always drop after the airplane stalls. So why am I mentioning all of this? It's because this is key to knowing how weight and balance works. Before you go fly every time, you need to do a weight and balance calculation. And this will tell you whether or not the center of gravity is within the limits specified by the airplane manufacturer. I'll show you how to do one in an upcoming video, but for now, just know that there's a limit and you have to be within it. You don't want the center of gravity too far forward because the airplane will have a hard time lifting off the ground, and also when you come in for a landing, the airplane might not be able to support all the weight in the front and the nose will come down pretty hard. You don't want the center of gravity too far back because on takeoff you could hit the tail, and if you get into a stall, you might not have enough elevator control to push the nose forward to reduce the angle of attack and get the airplane flying again. Let's talk about another thing that creates lift, and that's your wing flaps. Once we talk about them, you can transfer that knowledge to understanding how the rudder and the elevator work, because they work in almost the same way, just not to the same degree that the flaps work. The book definition of flaps is that they increase the descent angle without increasing the airspeed. And that's fine and dandy, but what exactly does that mean? Flaps are on the inside of the wing, close to the fuselage, and they are lowered for landing, sometimes for takeoff. As you lower the flaps, the curvature on the top of the wing will increase. The wing will be more curved because the flaps count as wing now when they get extended. So there's more curvature on the top of the wing, which means more lift. And also now the angle of attack is between the leading edge of the wing and the trailing edge of your flap. So that angle of attack is increased, which means more lift. So flaps are used to create lift. But anytime you create lift, you also create drag. And if you create drag as a byproduct of creating lift, we call that induced drag because it's a byproduct of creating lift. Anything else that's sticking out, let's say your hand out the window, that's called parasite drag because it doesn't produce lift, it's just sticking out there. So induced drag is as a result of producing lift. So when you lower the flaps, they increase the angle of attack, which means they create lift. But now they're also sticking out into the airflow, so they're creating drag. If you think back to the definition, it says that flaps increase the descent angle without increasing airspeed. And what happens is, as you lower flaps, they will create drag, which means the airplane will slow down, and when you're coming into land, you want to maintain the same speed on the way down. So if you slow down, you'll have to push the nose forward to maintain the same airspeed. So now the airplane is pointed down at the ground a little bit more, which means you have a higher descent angle, but your speed is still the same because you're trying to maintain that same approach speed for landing. If you understand how flaps work, you can take that knowledge and apply it to how the rudder, elevator, and the ailerons work. So the ailerons, one goes down, the other one goes up when you turn, and the one that goes down will create lift. The one that goes up will also create lift, but they'll create lift on opposite sides of the wing. So depending on which way you have the controls, the airplane will roll either left or right based on which aileron is up and which one's down. The elevator and rudder work the same way. When you deflect the control surface, you're creating more curvature, and that curvature results in lower pressure and pulls the tail in that direction. And the airplane can rotate around any of the three axes that we talked about in order to be able to climb, turn, descend, and yaw. The airplane propeller is basically two wings that are connected in the middle, and they're stuck in front of the airplane, and they spin. And as they spin, there's air going over the top, or over the front now, and the back of the propeller, and there's low pressure in the front, high pressure in the back of the propeller, and that creates thrust in the forward direction. That about covers basic aerodynamics. Make sure you check out part 2 for more aerodynamics, and as always there will be a link in the description to the Pilot's Handbook of Aeronautical Knowledge where you can read more about aerodynamics, and if after reading that you still have questions, leave them in the comments below. And until next time, have fun, fly safe, and always keep learning. See you next time.